Okay, here's the pivot system. I've got a little bronze bushing, and oops, it just looks like this. It's a 2mm bushing, and it's got a light press fit, and I wanted it to be able to hold on a little better, so I put some epoxy. I scored the sides, and then I put a little epoxy around the sides. This has a little bit of grease on it, and then that's going to have a little metal washer on top of it to rub. And then the pivot pin is a short length of 2mm diameter pin. Okay, so here's one of the pivot blocks. I've got a slit fit on the top, and then it presses through, and then there's a press fit on the bottom. So I'll put a washer on there, put it through the bushing, and then press it together. It also has some of this O-ring belt. It's kind of this green O-ring belt. There was a hole here, and I just cut a length of the belt and stuck it through the hole, and then used some goop to glue it in place, and that will be a bumper. You can see that on this one too. Maybe it's easier. So there's a bumper there and a bumper there. So the pivots end up looking like this. If I can get that there. So they go plus or minus 45 degrees and pivot on the end of the arm like that. Alright, I have to make an airfoil out of balsa wood. What I did was I printed up a couple half pieces of wing and screwed those on the ends of this board. And then I took a piece of scrap balsa wood, cut it to length, and I used some of this thin double-sided tape. This is used for window insulation. And then I attached this balsa to this piece of 2x4. And so this is going to act as the pattern, and with one on each side, and I'm going to sand this down. I've already been working on this one, but I'll sand it down until it's an airfoil shape, or half the wing shape. So here I have a board, and I used some Super 77 to glue a piece of 100 grit sandpaper. 150 would be good, I don't know, but it seems to work. And then I just move this back and forth and just keep sanding until I hear these things dragging on the wood below, and just sand until yes, so you can kind of hear it dragging there. So this airfoil is pretty close, but it's a long process. I think tedious would be a kind word for it. But anyhow, that's how I'm shaping each wing half, and then I'll glue the halves together. Alright, I balanced the wings using the cup method, just putting weights in here. Turns out it needed 16 grams. So I'm going to put one of these stacks on each pivot, and these are 8 grams each, so 2 of those 16 grams, and that should balance out the wing. I applied goop to the wings and glued them in place, and you can see that it's approximately level with these 8-gram weights on each of the pivots. I think if I was doing this again, I'd mount these differently, but this is approximately where it would be for the minimum moment of inertia. So I wanted this thing to be able to pivot quickly because I have a feeling the RPM is going to be fairly high. So anyway, I'm going to wait for that to dry and then take it outside, see how it goes. Okay, so just to review, this is a Sharp type turbine. It's got a pivot that's a 1/4 cord inward from the leading edge. You can see that little pin where it's at. There are some little rubber stops to limit the motion to plus or minus 45 degrees. And we've got counterweights on there so that if this was spinning very quickly, the blades would be horizontal or perpendicular to these arms. So it's 0.6 meters in diameter. I did that because I wanted 0.2 solidity, which is quite low, and 40 millimeters was about as small a wing as I wanted to make. So if you do the math with 3 wings, the diameter is 0.6 meters, and then I got just to get some area and to make sure it's got a good length to chord ratio, I made them 400 millimeters long. So that's 0.24 meters, square meters in area, which is not much smaller than the one that's out there. My thinking is that I like that turbine, but I think we can do a little bit better with a lower solidity to get more air into the turbine itself. And to get more air in, you go with a lower solidity. But to have the lower solidity, then you have starting issues, and that's why we have the Sharp VAWT. Let's see how it does. We've got a little bit of wind here, you can see in the other turbine, and I'll let this go and see what happens. So you can see even with the low solidity, it has no problem starting, and it seems to be doing pretty good. Those are pretty small wings, so I'm just waiting for the wind to pick up here a little bit. I think what I'll do is take the generator off that other one and put it on there. It's got the same base for it. Maybe I can make this one make power. So we just have a real light wind, and I'm just going to let it go and you can see it start. I just added the generator from the previous turbine just to see if this will generate power like the other one did. Just taking some wind measurements. See if we can get a tip speed ratio estimate. Got around 4 meters per second in that little puff. Now it's about 3.6. 2.7,